factoring a binomial. If you have two terms polynomial, for a binomial, two terms, check for the following patterns. Difference of square. If you have x squared minus y squared, you're going to remember this is the same as x plus y times x minus y. You can easily verify this by simply multiplying this. If I multiply the first term times the first term, they give me x squared, which is right here. And the last term times the last term, I get minus x squared. You notice that when I multiply the two closest term and two furthest term, here if I multiply two closest term, give me xy, and two furthest term, if I multiply these, give me minus xy. That would always add up to 0. That's why you end up getting x squared minus y squared. This is one of the formula that you need to remember. Difference of square would be x plus y times x minus y. Now x and y could be expression. Doesn't have to be a single number or term. We're going to look at those as well. The second one is difference of cubed or sum of cubed. Okay, you notice that with the difference and sum of cubed, the sign of these first term, first parentheses, matches the sign of difference for sum of cubed. That's one way to remember it. So if I have x cubed minus y cubed, you need to memorize this. So you need to find a way to memorize these two formulas. If I have x cubed minus y cubed, so the first term would be x minus y. If you have x cubed plus y cubed, the first term would be x plus y. So that's the easy way to remember it. The signs matches. And as you notice that the format of this is exactly the same. It's xy here. And in the second parentheses, both of them would start with the first term square, ends with the last term square, and the middle term for both of them is the product of the first term times the second term, so it would be xy. So that's easy to remember. The only difference here is the sign here. You have to remember that if the first parentheses has a sign of minus between them, if there's a difference of cubed, the sign of the second parentheses always would be positive. Just remember that. And then if the sign is positive, if it's the sum of cubed, it looks like the sign of the second parenthesis altered between plus and minus. Would be plus, minus, plus. That's just one way to remember this. So you need to write this down and maybe 10 times to remember these, as many times you need to. Maybe make a flashcard out of this. That would be another way to remember these formulas. Without it, it's going to be pretty difficult to factor difference of cubed or sum of cubed or even difference of squares. So let's take a look at more examples here. The first example here, we have 36x to the power of 2 minus y squared. First, we need to recognize that this is a difference of square. So in other words, I'm going to open two parentheses like that and make them square and ask myself, can I make these perfectly squared? 36, well, 36 is obvious. 6 times 6 would be 36. X squared would be x. So the first term obviously is 6x. If I take 6x and multiply by itself, 6x times 6x, that gives me 36x squared. So the first term is perfectly square. So as the second term, y squared. So I can identify my first term and the second term here easily. And if once I identify that, then I can use my formula. Difference of square would be a plus b times a minus b. You can switch these two terms around. You can put a minus b times a plus b. Doesn't make a difference. But once I find out what's my first term and what's my second term, then I can factor these out. So it would be 6x plus y times 6x minus y. Second example here, we have a sum of squares. The sum of squares you want to remember is this binomial is prime. It's not factorable. So once you see sum of square, you just stop and it says this is prime. We cannot factor anymore. Only difference of square can be factored this way. If we look at the next example, looks like we have a difference of cubed here. To see if this is a difference of cubed, we're going to open two parentheses like that and make a cube sign there. And this is difference, so with the minus here. I can have to ask myself if 125 is perfectly cubed. It sure is. 5 times 5 times 5 is 125. And x cubed is perfectly cubed. X times x times x is also x cubed. So the first term is 5x. If I cubed 5x, I get 125x cubed. So I can identify my first term, and then we do the same thing with the second term. Is 27 is perfectly cubed? Sure is. 3 times 3 times 3 is 27. So my second term must be 3y. If I cube 3y, I get 27y cubed. Once I identify my first term and the second term, then I just have to substitute that into the formula that we were going to memorize. The formula says, write the first term minus the second term. My first term is 5x, second term is 3y, so it would be 5x minus 3y. And in the second parentheses, we're supposed to square the first term and square the second term and place it into for the first and last term here. And we are exactly what we're doing that here. First term is 5x, and when I square them, it becomes 25x squared. The second term is 3y. When we square them, that becomes 9y squared. And the middle term was supposed to be a product of first term and the second term. So 5x times 3y, that is 15xy. Remember, if this were a difference of cubed, the sign in the second parenthesis was all positive, and that's exactly what we have here. So by just remembering the formula and finding the first term and the second term, we can easily factor difference of cubed.